I welcome you to this session of logical reasoning. In this session, we will take a look at the concept of calendars. Now, most of these competitive exams might ask you questions based on calendars, and although these questions are based on simple arithmetic, but one needs to be exposed to these questions to get them right in the examination with fair degree of accuracy. One thing that people need to know to solve these questions is that there are 7 days in a week, and therefore a day will repeat after exactly 7 days. For example, if 1st of August is a Monday, after 7 days, that is 8th of August, will be a Monday too. Similarly, if 8th of August is a Monday, then 8 plus 7, 15th of August also will be a Monday. So let us say today is 16/10/2009, that is 16th of October 2009, that is Thursday. So 7th day from today should also be a Thursday. Similarly, 14th day from today also will be a Thursday because 14 is a multiple of 7. And 56th day from today, because 56 is again a multiple of 7, 56th day should also be a Thursday. So far we have only calculated days which are in multiples of 7. But suppose there are some days which are not multiples of 7. Let's say I want to calculate what will be 17th day from today. So what I need to do is divide 17 by 7 and calculate the remainder. The remainder is known as the number of odd days. In this case, 3 is the remainder and therefore 3 is the number of odd days. So if I calculate 3 more days after today, I will get the 17th day from today. So if today is a Sunday, then Monday, Tuesday and Wednesday. So 17th day from today must be a Wednesday. Let us see. So 16/10/2009 is a Thursday. So 8th day from today. So I will divide 8 by 7. I get 1 as the remainder. So when I divide 8 by 7 and when I get 1 as the remainder, I just add 1 day to this Thursday. So on adding 1 day to this Thursday, I get Friday because 1 is the number of odd days. And number of odd days has to be added to my reference date. In this case, the reference date is Thursday. And remember, you have to count the number of odd days after the reference day. Let us say I want to calculate 16th day from today. Again, I divide 16 by 7. What is the remainder? The remainder is 2. And what is my reference day? Thursday. So I will calculate 2 days after Thursday. So the first day is Friday and the second day is Saturday. So 16th day from today must be a Saturday. Similarly, what about the 60th day? Again I divide 60 by 7. I will get 4 as the remainder. And in this case, 4 will be added upon to my reference day. So I'll count 4 days after my reference day, that is Thursday. So Friday, Saturday, Sunday and Monday will be the 60th day from today. So what does it mean? The total number of days when divided by 7, the remainder is known as the number of odd days. In questions of calendars, the counting has to be done only for calculating the number of odd days. If you know the number of odd days, everything else is simple. While calculating the odd days, many a times we will encounter leap years. So it is important to understand the concept of leap years because I feel commonly people are not aware of the total concept of leap years. So when we talk of a leap year, which of the years are considered leap years? Everybody knows that if it is a non-centurion year, that means if the year does not end in two zeros, then leap years are all the years that are divisible by 4. So non-centurion leap year are all those years which are divisible by 4. For example, 1976, 1996, 1984, etc. But in case of a centurion year, And by centurion year, I mean all the years that end in two zeros. So in case of centurion years, leap years are those years that are divisible by 400 and not by 4. For example, year 1200, year 1600, year 2000, these are all leap years. So suppose we have a date 1/1/2004, 1st January 2004, and we want to calculate what 1st January 2005 will be like. So if say 1st January 2004 to 1st January 2005, because 2004 is a leap year, the number of days is 366 days, and 366 divided by 7, we get the remainder as 2, which means in one leap year the number of odd days are 2. So how does it affect? For example, if 1/1/2004 is given to us as Monday, then 1/1/2005 will be 2 days after Monday, and that is Tuesday and Wednesday. So 1st January 2005 would have been a Wednesday. Similarly, if 1/1/2003 this date is given and we are required to find the date 1/1/2004, again it is a normal year, so it has 365 days. So just divide 365 by 7 and we get the remainder as 1, which means that there are 1 odd days here. And therefore, if the date 1/1/2003 falls on a Monday, then the date 1/1/2004 will fall on one day after this Monday, that is Tuesday. So ordinary year is 365 days, that is one odd day, that is one thing we need to remember. And a leap year is 366 days, and that implies 2 odd days. Now let us solve one example. If 12/4/2006 was on a Monday, then what day of the week will be 12/4/2009? So this is what we've got to calculate. So how to start? We start by counting the total number of years. So in this case, the total number of years are 3. And out of these 3 years, 3 odd days must be there, because each year stands for 1 odd day. But there is one year which is a leap year. So 2008 is a leap year, and in this year there must have been one extra day, because in leap year there are 2 odd days, and we've counted 1 odd day in these 3 odd days. So we've got to count one more extra odd day. So the total number of odd days are 4. So we count 4 days after Monday, that is Tuesday, Wednesday, Thursday, and Friday. So 4 days after Monday is a Friday. Therefore, 12/4/2009 must have been a Friday. Let us solve one more question. If 27/1/1920 was a Saturday, what day of the week would 27/1/1962 have been? Again, the key lies in calculating the odd days from 27/1/1920 to 27/1/1962. So in a century, leap year occurs every 4 years. This is a known fact. So if total number of years are 42, then the leap years must be 11 in this case. Now why 11? Because if the total years are 42, and I divide 42 by 4, I'll get 10. But the starting year itself is a leap year, and therefore I will add one more to the 10 and it will give me 11 leap years. Mind you, when I divide 42 by 4, then the quotient also gives me the number of leap years normally. In this case, I have also added 1 because the starting year was a leap year. So 42 by 4, 10, and hence 11 leap years. Total odd days is equal to 53. How 53? Because 31 are normal years, and for each normal year we have one odd day, and 22 for the leap years because there are 11 leap years. So 31 plus 22 gives me 53. So the total number of odd days are 53. So 53 divided by 7, we get 4 as the remainder. And once we get 4 as the remainder, we know that it must be 4 odd days after Saturday. So we count 4 odd days after Saturday, that is Sunday, Monday, Tuesday, and Wednesday. So 27/1/1962 should have been a Wednesday. Now you must note again that if starting year is counted as a leap year, then the number of leap years are one more than the quotient of total number of years divided by 4. So with this we come to an end of this session on calendars. In case you have any feedback or any queries, please feel free to write to us at studentservices@pfindia.com. Thank you.